Hello, everybody, and happy Friday. Welcome to May. I'm excited to be here today. Excited to have you all on. We've got a lot of people here, and I can kind of guess why. We have a very special guest joining us today. But again, just getting started. This is interactive, so we do want you to interact with Q&A. So there's an opportunity to ask questions in the bar on your page. Feel free to start doing that at any time. We will have some dedicated time for Q&A at the end, but if the question makes sense throughout the presentation, we will try to address that along the way. There's also resources you can download on the page. There's also polling and survey questions. So at the end, there'll be an opportunity to answer some survey questions, very helpful for always improving. And then we also have some polling questions, which will be aggregated and help guide and engage with the audience and ourselves throughout. And lastly, if you're here and trying to get CE credit, there will be a bar where you can set that up. And feel free, if you have questions that are along that route, you can also ask that in the QA box as well. So today, I'm Zeno Mercer, and I lead research for Robo Global. And today we'll be joined by Daniela Roos, who is one of our esteemed advisors and one of the leading voices and pioneers in robotics and AI. I will give her a proper introduction in a second, but just real quick, today's agenda. We're going to talk about the current state of AI, where things are heading, where it actually stands today. We're going to talk about robots too. We don't say robots on this page, but there's a lot happening in the robotic space that I'm sure already see people asking about that. We're going to talk about the investment landscape and how the intersection of AI and robotics, what that means for these newer areas, but also what's happening in traditional sectors as well. And we're going to look for hidden opportunities and talk about valuations, and also, very importantly, we're just going to talk about the future outlook. So again, I'm Zeno with Robo Global Indices, now part of Edify. We were the world's first robotics index and associated products like ETFs launched in 2013. We now have an AI strategy and a healthcare strategy called Think, THNQ, and HTEC, HTEC. We're a very kind of think of us as like deep equity research that ties into the different subsectors and core areas of robotics, AI, and healthcare innovation. So looking at both kind of the macro big picture and the end markets of what's driving that, down to the individual technologies that companies are building out themselves, their technology leadership, their market leadership, and all these things. Now, today, we're going to be joined by Daniela Roos, who's one of our strategic advisors who guides our research process. And so Daniela, a little bit about her. She is currently, among many things, the director of MIT's Computer Science and AI Lab, often referred to as CSAIL. She's the co-founder of Liquid AI, which raised $250 million, I believe, in December of this last year. And she, give her an opportunity to talk about that. She's the recipient of many awards, such as the MacArthur Fellowship. She's a member of the National Academy of Engineering and the Engelberger Robotics Award, which many equate to being the Nobel Prize of Robotics. Without further ado, Daniela, I'd love to welcome you to the floor. How are you doing today?
Hello, Zeno. Thank you so much for this kind introduction. I'm so excited to be here. And I'm really excited to get all the audience questions. This is such a special moment in our technology. AI and robotics are palpably changing the world, and there are so many opportunities.
Yeah, of course. And we already have one question in so far. We definitely will get to that one. I don't want to spoil that, but maybe we can kind of just start with the current state of AI. And I guess we can also lump in robotics here. But I just wanted to start with, obviously, there's a lot of news around, the tariffs and geopolitics. There's export controls. But we are seeing, there's kind of some conflict happening, but we are seeing a big push to reshoring. And I would say a lot of this probably has to do with the ability that we are, improving the ability of robots to help create, chips. We've got Taiwan Semiconductor accelerating investments in the U.S. Data center CapEx was just recently shown to be increasing at companies like Meta on their most recent earnings. But I guess, Daniela, are you seeing, chips are a big part of AI. You use chips both from, computer servers, and you're also building companies that utilize chips and try to make them more efficient. Are you seeing any impact so far? Or, where do you think about the state of semi chips and what's happening in the world today?
Well, chips remain extraordinarily important, and we see that we have ramped up production, and this is helping support many companies that are really trying, that are aiming to bring value to the world through AI and through computation. I will say a few things. So you mentioned manufacturing, and this has become very important for the U.S. But I will say bringing back manufacturing cannot be the manufacturing of the 1950s. It has to be manufacturing supported by computation, supported by AI, supported by robots, supported by generative AI for design. So there are so many opportunities for the AI and the robotics community to create the tools that could really give the United States an edge in designing and making things. Now, of the many things that we can design and make, chips are one of them in general electronics, although manufacturing is much broader than that. With respect to chips, I'm super excited about, first of all, about the efforts from both NVIDIA and AMD to create different types of architectures to connect the chips better to the AI infrastructure that is needed by companies and to support the developers of AI solutions to bring their AI models in the most efficient way to their servers. This also leaves an interesting opportunity open. And the opportunity is to consider how might we improve the chip design itself. Right now, the chips are fairly general, and they are rooted in ideas that we have incorporated in our chips for many years. Initially, the GPUs were designed for graphics processing, and then we found that they were very good for the kind of computations that AI is based on. But what about making special purpose chips? What about thinking about how we can take chips and we can design them to fit particular AI models so that they are the most optimal computational platforms for those models? And you see, a lot of the world today is adopting transformer architectures for AI, and the transformer architectures are very powerful, and they're bringing us extraordinarily interesting capabilities. They're also very huge computational platforms, and we have seen recently through the work of DeepSeek that we can begin to aspire to more efficient computation. We have also seen recently that scalability on transformer architectures might not necessarily bring us the capability that we imagine. We're beginning to see diminishing returns of pure scaling. And so companies that understand this and are finding ways to adapt what they create by bringing additional computation, by connecting AI with other tools, maybe with modeling, maybe with simulation, maybe with planning, maybe with other ways of bringing reasoning, will have better products. So chips tailored to specific AI architectures and models, chips tailored to specific energy requirements could really be game changers in this space. Now, in addition to transformers, we're beginning to see the rise of other kinds of AI models, including the AI models that we are building at Liquid AI.
That's right.
And so I can
Liquid
talk.
announced some new updates recently. The Hyena architecture, right?
Well, exactly.
Yeah.
So there is a lot of opportunity to do innovations in the state space model like suite of AI architectures, and these state space models are actually very powerful. Now, if you look at the paper, the original paper about transformers, which is called "Attention is All You Need," one of the first sentences in that paper says, "We do away with convolutions and with recurrences in order to enable more efficient parallel computation." So doing away with recurrences means we're not building loops in the AI solutions. It means we're building feed-forward systems. But loops are very important for intelligence. We learn from our past experiences. Well, state space models bring this idea of a loop back into the model. State space models also tend to be rooted in more physics-based computations, and that makes them much more capable of representing spatiotemporal correlations. And so if we're building AI solutions for robots or for other physics-based processes, whether in healthcare or in energy management, where it's important to understand the physics of the world and it's important to be able to represent task constraints, then these state space models are extraordinarily powerful. And so the question is, what would a chip that is targeted to transformer computations look like? And how is that different from a chip that would be targeted to a state space model? These are still open questions. There are companies that are beginning to ask the question of how do we build customized chips. And so for the investors out there, I think that there will be a lot of benefit from investing in these kinds of companies, in these kinds of startups. But just to go back to the high level question, there is a lot of opportunity. There's a lot of specialization, and we see a lot of companies bringing AI solutions to the world. All these companies need data and they need computation. And so data centers continue to be very important.
No, that's right. And I mean, obviously, I think a lot of people think of AI as living in data centers, but you brought up a couple points about energy efficiency and specialization, which, you don't put an entire server out in the world. It's obviously operating locally. So you do have that world where you are understanding physics and you're not just understanding text or 2D or, I mean, even OpenAI, the latest models can have pretty good contextual understanding of 2D images, but it's not operating live with low latency, good efficiency, where it would be able to operate, a drone that was in your home or, other use cases. And I think part of this people are understanding is like, okay, we're investing all this money. Like, where does it lead us to? There's a lot of money being, put into building not just the wafers, but the chips and servers in the US, but obviously the edge compute and robots that'll come out. So these are kind of new markets that weren't really possible before this type of technology coming together, right?
Yes, Zenon, thank you for setting this up because this is exactly what liquid networks are going for. So liquid AI creates these small models we call liquid foundational models. And these models have demonstrated increased performance on very challenging metrics as compared to existing models. And this increased performance is happening in a compact form. So like at 1 billion, 3 billion, 7 billion, 40 billion parameters as compared to hundreds of billions or trillions of parameters. Liquid networks also have an added advantage of using much less memory as compared to other models. And this allows us to create AI that can run on edge devices, where the edge device is your phone or your enterprise computer or a satellite or the computers associated with a power grid or airport operations. Moreover, because you can run these models locally without cloud calls, these models can also be very effective at delivering private and safe AI. Because now you don't make cloud calls, and all your data and all your interactions with your AI system can reside locally. And so I'm super excited about the opportunities that this enables. Whether you have a small and real-time computational environment like the computers on a car, or you have your phone or your desktop computer, or you have a small cloud that is built on the premise of your company. The applications that get enabled are really extraordinary, and so we will see increasingly more of that. Check
Yeah.
out the website of Liquid AI, which talks about some of these benefits. Also, I should say that the Liquid AI technology is much more efficient for both training and inference. And so we have trained very capable models using on the order of hundreds of GPUs as compared to tens of thousands of GPUs, which is more the state of the art. And we observe energy improvements anywhere from 100 to 1,000 times the consumption of the state of the art. And this energy improvement is not just for training. The energy improvement is both for training and inference. And
Right.
inference is a particularly important aspect. We often talk about how much energy it costs to train the model. Well, we do inference much more than we do training, because once a model
Exactly.
is trained, it can be used over and over and over again. And
It
so
should be,
inference,
because otherwise, what's the point? And I think, it's like we're trying to build models that are adaptable, sustainable. We've had a couple of questions around, like, do we need new, efficiency gains in models? And I think you've answered that. Like, clearly we do. And if you're running an edge device, kind of a similar, story would be like a human brain doesn't need to operate a fly. It makes no sense. It's not the right architecture. It would consume too much energy. So I think that we kind of see that same thing. Now, another thing I'd like to kind of talk about is even Microsoft and Alphabet just reported earnings, and their CEOs basically just said that around 30% of their code is now AI generated. So someone had asked, like, are we going to see AI designing its own chips? Well, right now we're seeing enterprises designing their or co-designing with humans code. So where do you think we're directionally headed with that, and what are the implications, Daniela?
well, it's so exciting. We can see AI generate exceptional code, much more powerful than a year ago or 2 years ago. But it's important to remember that when code gets generated by AI, this is a collaboration between human and AI. AI does not yet have capabilities to solve problems. But with a human in the loop, you can generate extraordinary things. I was recently preparing for a presentation about AI to a group that invests in real estate. And well, that's not my area. But I sat with one of the chatbots, and I asked a bunch of questions. I gave a bunch of guidance, and I was able to get the chatbot to generate interactive dashboards. I was able to generate very powerful code. I was very impressed by that. So this kind of vibe coding is
Yeah.
empowering non-experts to have the benefits of computer programming
I
without
love
really
hearing you say
needing.
vibe coding because I think it's interesting because in a way, almost everyone on this call could probably vibe code something with their family, like a little game or something. Like right now, things that used to require lots of teams and UX design now can be communicated through text, and with the computer understanding what the intent is. So, I mean, in one of your books, you talk about the heart of the chip, about kind of like AI giving people superpowers, and it kind of just what you just said sounds like you've been given a superpower even in what you do. And so, one of those areas is obviously like, where does adoption head from here? We saw Shopify, which is in the Think Index, THNQ, just announced a partnership with OpenAI. So now people are going to be able to like shop with OpenAI. We're seeing Waymos in autonomous vehicles. Like, so, how do you and where do you see kind of like the current state of AI adoption in the way that everyday people interact with AI, and where is this heading? Like, where are the benefits or even silver lining negative elements that could exist?
Well, let's see. So I actually am very excited about the possibility of empowering people to use the power of computing, even if they're not trained as computer scientists. But I also want to bring up a cautionary statement, which is that today's models, the transformer-based models, do hallucinate. And so we cannot trust uh, everything that comes out of those models. So we get support, we kind of get the support of a super intelligent assistant, but the human expert still has to check the answers. The human assistant has to help guide the process of the AI system. And so that's important to keep in mind. When we see this extraordinary performance, we tend to say, "Oh, this is really good. I'm going to trust it." But we are not yet at the point where we can have great confidence in how the models work. However, there are startup companies that are bringing that trust, that confidence to bear. And so, for instance, our startup called Themis AI is doing exactly that. Our startup is taking models and turning them into trustworthy models by removing the uncertainty, by removing biases, by removing some of the problems with the model, and also
Are these
by
kind of like
having the
guardrails in a way? Like if you had to kind of translate that, they're kind of like guardrails to like a locking into reality or specific.
you
Um,
can Yeah, you can think of them as guardrails, but actually, what Themis does is Themis understands the connection between uh, the the data uncertainty and the model uncertainty, and
mhm.
it's able to take the model and kind of transform it. So that there is a wrapper you can put onto a model, and that wrapper allows us to transform the model from a vanilla model into a model that is uncertainty aware, that tells you where the mistakes are, that actually literally highlights the hallucinations in your model. So you can
Interesting.
take like a chatbot, like a llama model, and use it to generate text. And with these tools, you will be told when your model has hallucinated. Or if you have a diffusion-based model where you're drawing stuff that is incorrect and inconsistent, you as a user will know that what parts of the generated output are incorrect. And so I'm very excited about the possibility of strengthening all these models. Now, I have to tell you that I just finished a PhD defense for one of my students, and I want to tell you about it because I think it's interesting to the audience and to where the technology is going. You asked that question. So in our in this PhD defense, my student looked at manufacturing. My student looked at the partnership between human and machine to create designs that meet task specifications. And
Mhm.
so it's interesting, right? You could start with a very straightforward textual prompt, like I would like a device, an end effector that can manipulate pliers, or I
Right.
would like an end effector that can push a syringe, or that can manipulate a pipette. So choose your task. So you can say in words something like that, and then the system, a natural language system, your favorite chatbot, can take that query and say, oh, if you want a robot end effectors that can manipulate a syringe, you have to hold a syringe and you have to be able to push a button. And so from this kind of interactive back and forth, the human and the machine can actually create not just a design that meets that specification, but also code that drives that new design. And so it's kind of exciting to think about how much efficiency we will get in for the invention and testing of new products, and how much quicker we can bring those products to the market with these new AI tools.
That's an incredible advancement. I think that probably is underappreciated how much that of a game changer that is in terms of kind of just like, yeah, exactly, the product development cadence, and also being able to, for these models to understand the physics of what the intent and goal is and help design it. Again, these are things that used to take a lot more resources, a lot more testing and iterations, and now obviously we're seeing a lot of these things could then go into simulations. So I think like we're seeing a lot of these steps that used to be required are now being condensed. It's almost like we have like a time machine being able to help support these elements. Now, real quick, we're going to do a poll. So just quickly, everybody here, I just wanted to get a sense before we move on. If you had any allocation to the following sectors. So we've got robotics, AI, and healthcare innovation, or no. And this is just curious. So we'll sit here for a minute. So thank you everyone for participating. We'll see here. Okay, I'm gonna move forward now. Okay, so Daniela, the audience, this just for a sense of where the audience is at with us today. And again, this doesn't mean they have knowledge or don't have knowledge of these things, but we've got about 45% of the audience is allocated into AI, about 27% in the robotics, a lot less into healthcare, and a pretty solid 50% no. And so I thought maybe it'd be interesting. We kind of talked about the AI tomorrow. I think we've already gone over some of this, especially kind of manufacturing. But what are some of the other areas or like impacts that you see happening? From maybe not so much an investment standpoint, but from like our lives standpoint, because we have some of the kind of topics here across education, logistics. I know one of the areas you focused on or have focused on is kind of like modular systems and soft robots, and how robots can interact in more of our daily lives, not just inside of warehouses.
So, Zeno, that's an excellent question. But may I first react to the poll?
Yeah,
I note that a lot of the listeners are actually not invested in any area related to artificial intelligence and robotics. So I just want to share that I really see this moment in time as an extraordinary point in time where all industries will be able to benefit from AI and from autonomy and automation, which is what comes from robotics. And I feel like everyone is trying to figure out how this will be happening. There is a lot of push to undergo the AI transformation, just like there was a lot of push to undergo the digital transformation in the years 2000. If you can remember those years, I still can. And so I think that the companies that will embrace AI and will manage to transform themselves, will manage to successfully embrace the AI transformation, will be the leaders. They will be ahead of the companies that do not. And right now, we don't have so many AI native companies, but we will also see an increased number of AI native companies. Mm-hmm. Now, with robotics and automation, this AI is coming to the physical world. And right now, there is a lot of opportunity in warehousing and in transportation and in retail. There are so many opportunities, both on the robotics side and on the AI side, for inventory management, for fabrication, for managing, for supply chain management. So these are like, there is a lot of action already by big players and also by many startups. But there are many other spaces where the AI technologies and the robotics technologies will have an impact. Agriculture is it's an obvious sector, and we already see a lot of activity in agriculture. Everyone needs food, and the more efficiently we can ensure that food is produced, the better. Similarly, agriculture has a kind of a large impact on the environment right now.
Hmm.
Agriculture uses a lot of water. Agriculture uses a lot of chemicals, which are not so good for the soil. So the more precise we can deliver these resources to the plants we cultivate, the better. There is also a lot of interest in building indoor housing. There is interest in using AI and robotics techniques to monitor livestock. And through this monitoring, we are then able to understand where the animals go. Is the farm really organic or not? If an animal is diseased, we know exactly which animals were nearby this animal, so that we can respond in a much more precise way. So agriculture is really ready to explode. Construction and real estate investment, I think, is also very prime to benefit. And on top of that, of course, we have healthcare and finance, which have been, and these are sectors that have been much faster technology adopters than, say, agriculture and construction and tourism, the sectors that traditionally were a bit slower. But what I see is that every single aspect of the economy is ready to embrace the AI transformation.
It sounds like, I mean, there are a lot of concerns. To circle back to, we had talked about kind of like energy earlier, and there's the chip and server level energy, but the current world's operating model is, you've mentioned a lot of low hanging fruit, which seems like it would reduce waste, improve efficiency of like resources itself, which at the end of the day, I mean, we're a resource based universe. So do you think, and putting you a little bit on the spot, that as we look at all these different areas, like, do you think AI will solve its own energy needs, or like not even its own, like resource needs of efficiency? Like, people talk about ESG, but like in a way, what you've described is, deployment of AI could solve a lot of environmental issues, efficiency issues, even governance of just like observability of like how things operate. So, we kind of like tie that into like deflationary automation everywhere, but maybe love to hear your thoughts on kind of how, like, what does this all mean?
Well, efficiency is an important problem for AI. And whether you're thinking about using AI to solve environmental problems or manufacturing or healthcare or improving your financial practices, AI can help. But of course, in order to do all that, AI and in particular the kinds of models we're scaling up right now consume extraordinary amount of energy. And so an important question is, how do we make AI that is smaller, that is more energy efficient? And there are methods that we can employ. So the research community has been asking this question for years. The research community has come up with methods. For instance, you can take an AI model, you can fine tune it, and then you can prune it. Pruning means removing all the parameters and all the neurons that are less relevant. And if you want to apply AI within an industry vertical, then you can imagine that a huge model will focus the computation in specific areas of the model. That means that there will be great opportunity to prune it. So that's one method. Another method is quantization. So through quantization, the idea is to replace how we represent numbers. And this is important for you to know, because computers don't understand words and designs. Computers understand numbers. So everything inside that model is not actually a graph, but it's a bunch of numbers. And if we can represent those numbers using fewer bits, then we have smaller models and we have energy savings. In fact, DeepSeek has used these ideas, has used pruning, has used quantization, has used other excellent engineering tricks. They have applied great engineering, and they have achieved a factor 45-fold energy savings
And that's amazing,
in their
right?
solutions.
That's great
That's
for the
amazing.
world. Yeah, it's
So
amazing.
that's amazing. So that's one way. So one way to get energy efficiency is to take the existing models and to make them more efficient. And DeepSeek has shown us what is possible. But there is another way. And this other way is to really think about how do you design an energy efficient AI model from first principles. Liquid AI, which is commercializing our liquid networks technologies, started with this question. We wanted energy efficient models that could run on the body of the machine and that do not make mistakes. Because for robots and other safety critical systems, this is what we need. A robot car that's driving at 60 miles an hour cannot afford to make a cloud call and wait for 10 seconds to get the result, right? I
No.
mean, that computation has to run locally. So that means that we need energy efficient computation that can run on the computer that is on the car,
And,
that is on
you
your
know,
device.
that and I like the things you're mentioning, like in a way, are the tip of the iceberg, right? They're mandatory and they need to improve. But also, I mean, even with an autonomous vehicle, as you just mentioned, I mean, concepts like swarming and better, like not like the way like AI helps improve navigation and logistics, just focusing on that, wouldn't we see enough kind of like efficiency gains that offsets additional energy cost if AI even has additional energy cost, if that doesn't solve itself?
Well, I want to say that AI should not really be so energy hungry. I want to really believe that with our solutions, we can bring AI just like a regular service, computational service. It will consume some energy, but not the kind of numbers that we're talking about now. And so that's number one. Number two, even if we have more expensive computation, we have to think about the trade-offs, just like you said, Zeno. We get something from using AI. We get something we didn't have before. And so I guess when I think about how AI and robots help us, I think about three buckets of problems, right? So AI can and robots can assist us. AI and robots can augment us, and
Hmm.
AI and robots can enable things that we cannot do yet. So we have seen a lot of focus. Many companies are focused on the assistance part of the problem. And so with AI and robots, we can get efficiency. We can get higher productivity. And typically this means this kind of thinking about AI as an assistant that requires the human oversight. But increasingly, we see augmentation where AI can begin to do independently some tasks so that in some sense AI augments the human, and we now have a human and a machine working side by side, working together. However, there is this new class of AI and robot capabilities which do not exist yet, and which through the development of these intelligent machines we can bring to the world, and we can bring ideas and capabilities that maybe we were not dreaming about 5, 10 years ago.
I think, I mean, these are fascinating topics, and I like those buckets you talked about because I really, at the end of the day, we hope, and I think people that are trying to build these systems are really thinking about, the macro, like the big picture for Earth and humanity, but also the individual level quality of life. And what a lot of things you mentioned are, we would consider improvements to quality of life, whether it's taking care of aging parents or even yourself. The efficiency of government resources. That's been a huge topic of Doge, but obviously, like if you want to look at what is Doge 2.0, like if we actually wanted to put a sustainable path forward on that, it would be more efficient allocation of resources based on the income coming in through taxes or tariffs or whatever it has you. And it seems like, AI and robotics is kind of the solution to that sustainable direction. Now, kind of moving forward a little bit, actually, I was going to move forward, but one thing we haven't really talked about yet, that kind of ties into that is humanoids. Um, and we've had at least one question about humanoids, but yeah, no, obviously, I think a couple things, like we saw China had a humanoid race for a 10K or a 10K humanoid race the other week. That seems like a kind of a silly task, but like a very maybe one of fundamental benchmarks, but obviously there's a lot of imagination of what humanoids could do in manufacturing and industrial and also inside our homes. what do you think we are in the state of humanoid development, and what are you kind of bullish and bearish on in terms of the impact it could have? I will add real quick that Morgan Stanley just came out with a report that they think uh, humanoids could be a $5 trillion market by 2050. I think that was the number. So that came out in the last week. So prefacing that, love to hear your thoughts on humanoids.
Okay, so I'm very excited about this topic, and I'm excited because I want to share that humanoid robots have been walking, talking, and falling over for decades in research labs. And what's changing now, it's
And
not
your
just how
research,
the
your labs
yeah,
too. Yeah, yeah.
exactly, exactly. So what's changing now isn't how they move, but it's how they think and they perceive and interact. It's how AI is also enabling them. But let's remember that the dream of building machines in our image that are smart and obedient goes back to the early days of antiquity. And the way I see it, this dream is still far off, but it's closer and maybe more complicated than ever. So I don't know about the 10K race. I haven't read about that, but I read about the half marathon race that was held in China. And so a group of humanoid robots attempted to run a half a marathon, and that was a few weeks ago. And most of those humanoids didn't make it to the finish line, but a few did. And that happened sort of step by careful step. And it was really quite an extraordinary display. But it was less a display of speed and more a display of persistence and just how hard real world mobility still is for machines designed to move like us and in environments that are a lot like us. And so when I watch those robots struggle and adapt, I am reminded of something very fundamental. Building a humanoid isn't just about legs and motors. It's about coordination, it's about perception, it's about whole body movement, it's about decision making in real time. And so I would say that we are seeing exceptional progress in humanoids. There are many companies that are building humanoids to the market. There are projections like the one you just shared, Zeno. Other projections show 30 billion potential by 2030. However, there's still a lot to be done in order to get the humanoids to be robust and persistent and work side by side with us in everyday life.
Safety. Yeah.
I see humanoids. I mean, the humanoids that we have at MIT can do some things really well, but they also fall often, and we see them as still complex mechanisms that are hard to control. We're now trying to use the humanoids to build something, and it's really hard to get this humanoid to balance so that it can bend to pick up a brick and set it next to other bricks to create. We were trying to build mosaics, and this is a research project. This is not this capability is not at the point where it's ready to be spun out into the world. Now, Elon Musk really believes that by 2030, so in 5 short years, the Tesla Optimus will be side by side with humans, and we will have millions of Tesla humanoid robots on manufacturing floors. And so I think Elon Musk has really great vision, and
Mhm.
I would not bet against his vision, but maybe the timing is not quite right. In fact, Elon Musk also told us that by 2021 we will be falling asleep at the wheel, and
I'm still waiting for that too. Yeah.
we're waiting for that. So with humanoids, I think it's important to remember they remain complex mechanisms that are hard to control. It's easy to hard code a humanoid to do a task. But getting that humanoid to be adaptive, to learn, to be
Yes.
able to perceive at the right rate, to really have intuitive interactions with the environment, is challenging. The other thing I want to say about this is that in the recent past, we have also become very excited about the potential of using language to the perception action loop that we associate with robots. And you know, when we add language to that loop, then something even more powerful happens, because language becomes the bridge between abstract reasoning and the embodied experience. Language allows us to raise the level of abstraction and computation that we have with robots. When we think about programming robots today, it's usually we usually have to consider XYZ coordinates and pixels, and it's really quite low level. But with
Pretty
language,
granular level. Yeah.
we can get robots to explain, to learn from humans, to align behavior with our goals, to interact with us at the same level of concept and abstraction that we have. And so it's kind of exciting to think about what it means to integrate language understanding into humanoid robots. And this promises to open the doors to intuitive human robot interaction. But then I'm asking, really, does it or is it? And so I want to share an experience I had today. I had about a month ago at a conference where a Neo robot was being demoed, and the Neo robot was really exceptional. We enjoyed watching it, and it was a lot of fun to see how far this platform has gotten. And so there was a kind of a home environment, and I asked Neo what it could do, and Neo said, "Oh, you know, I help people in the home." And so then I said, "Hey, Neo, can you water that plant over there?" There was a plant, and there was a watering can next to it. So Neo said, "Yeah, sure." And Neo kind of walked to the plant, grabbed the can, watered the plant. And then I said, "Hey, Neo, can you water my friend over here?" And Neo said, "Yeah, sure, no problem." And went to get the can and was ready to come and water the shoes, the beautiful, expensive shoes my friend had.
That's
And I had
hilarious.
to say, no, stop. I was just kidding. But the point of this is the point of this example is that these machines still lack common sense reasoning. And this
Yeah.
is hard to bring to to our machines. It remains a challenge for both digital AI and for physical AI. And the way I separate digital AI and physical AI, digital AI is the AI we use in the digital world for tasks that are inside our computers, whereas physical AI is the AI we use when we interact with AI in the physical world, the AI that we put on robots or on sensors or on satellites or on our other devices that exist in the physical world.
And right now, would you say most of the AI investment or current revenues are tied to digital or physical? It would be more on the digital, like the server side, right? Like we're in this giant digital capex super cycle right now, but this kind of physical AI is really, really early innings.
Exactly. So the digital AI is bringing us extraordinary capabilities in the digital world. But when it comes to the physical world, the chatbots we have today, the transformer-based systems, are statistics-based solutions. That means that they understand statistics. They do not understand the physical world. They do not have common sense reasoning. And so thinking about bringing those technologies into the physical world, on one hand, is very powerful, because just imagine AI's ability to understand text, images, and other types of online information. Imagine how powerful it would be to use that to make real world machines smarter. But we have to do that in a careful way. We have to do that with tools that have the ability to do spatiotemporal correlations, not just statistics correlations. We have to do that with tools that understand the laws of nature, understand physics. We have to do that in a way that has common sense reasoning if the machine interacts with people. And these are all challenges that we are tackling in the research community. These are also some of these questions have been addressed by liquid networks and are now part of the solutions deployed by liquid AI.
Yeah, I think that's a lot of mandatory, and I would say those are mandatory things to solve before we get out there. Obviously, we might see little versions appear, but I think we're at the getting closer to the Q&A time. But just from kind of a portfolio standpoint, obviously most of the I think perception has been in we just discussed AI investments have been mostly idealized or understood as being maybe enterprise like chat and sales and marketing and videos and text and kind of that digital. But obviously there's a body to AI. There's cybersecurity considerations. You've mentioned observability, kind of individual models and systems, but also the whole system level, how things coordinate and are shared. So one of the things obviously we work together on is constructing and developing the Think Artificial Intelligence Index, where we look at where is AI heading and what is the full kind of body of components necessary for AI to thrive. So it's not just digital and data centers. There's obviously going to be continual investment and bridges into the physical world. So just showing some people some of the things that we're considering as important for that ecosystem. And just real quick, giving a snapshot of the current state of the Think Artificial Intelligence universe. So, we have obviously semiconductors where, that the chip industry is expected to, I guess, grow by 50%, 60% to $1 trillion by 2030. That's a lot of projections. I think Taiwan Semiconductor just reaffirmed that number. And the fact that Taiwan Semiconductor is still under $1 trillion market cap, considering Apple and NVIDIA and everyone depends on them and they're expanding in the US, seems a bit crazy. We also have cloud providers. We've talked about cloud being kind of like this early spear prong of investment and consumption of AI, but Alpha, or I think AWS just reported 112 billion in trailing AWS revenue, which someone pointed out was more than over 450 or 400 other S&P 500 companies. That's just AWS alone. Like, we're already in this digital world and we're just getting started into this physical AI universe. And then, Shopify, I mentioned, or Shopify and Think, or Shopify is partnering with OpenAI. So we're going to start to see more, autonomous agents that will shop with your personalization start to appear. So, at the end of the day, there's a lot of different underlying, I like to call it kind of the body of AI, where, you have autonomous systems where you need cybersecurity. If you've mentioned all this autonomy happening, you need more network and security resilience, whether it's for uptime, but also just making sure everything's operating from an efficiency standpoint, but from a secure standpoint where, issues aren't happening. Just wanted to see if you had any, anything stood out to you across these subsectors or anything that you're thinking about that interests you in this universe here. Like, obviously we have healthcare.
Yeah, everything interests me, Zeno.
Everything
interests
by curiosity.
I feel like we have such huge opportunities, and I'm looking at your slide, and there is enormous potential for growth in each one of the boxes that you put up. Obviously, healthcare is a very important sector because healthcare impacts us so much, and so we have already made a lot of progress in healthcare due to technology. Now with AI, we will better diagnose, monitor, and treat disease, and this is really extraordinary. With AI, we will reduce road fatalities, and we will bring a lot of value to markets. I just read about the Toyota and Waymo recent partnership. So it was very exciting because I've been working with Toyota for a long time, and Toyota has and our approach to autonomous driving has taken a kind of a different approach. So we've been very interested in the partnership between the robot car and the human in the car as a way of leveraging what the robot does and what the human does. as a way of enhancing the safety and the efficiency of the pair. And so this is a different path that slowly marches towards level 5 autonomy, but that can be deployed more broadly, because we do not have 100% reliance on the on the machine. So I think that there's so much creativity in every part of the economy. And the challenge here is to bring the AI transformation and the autonomy and automation transformation in order to get more benefits, and in order to have those benefits translate into positive outcomes economically, but also for humanity and for our planet.
Do you think, I mean, obviously we talked about Tesla and Elon and not betting against them, but there are a lot of players in the humanoid space now, right? There's private companies, there's big public companies. So, in your point of view, like, is there a guaranteed winner? Do you think it's just a rising tide? Obviously there's a lot of components, but I mean, and this might be a biased question for both of us, is that, and this is the Think Artificial Intelligence Index. We obviously have ROBO index, Robo. But, I think, in our perspective, there are a lot of players going after this. So, being overly weight in any particular player, when there's so much that could happen, a bunch of tangents of possibilities, like we've kind of gone after a more kind of equal weighted strategy just to capture the broader ecosystem on one hand, but also capture that there could be a lot of players and it might not necessarily be, the leaders of today.
Well, absolutely. There are still some really big challenges to be solved before humanoids become products. And so, and we have a wide range of companies, as you said, building humanoids. Some of these companies are big companies, some are startups. And so, for instance, we have Tesla, we have Figure AI, we have Agility Robotics, we have Toston Dynamics, Unitary, X1 Technologies, Agibot. We have Engine AI, we have Engineered Arts, Fourier Intelligence. I mean, the list goes on. So there is a lot of enthusiasm. The problems are really hard, and so we need to keep this in mind as investors, as we go for investments in the space. We need to make AI better in order for humanoids to work better. The complex mechanisms require better support. The robot's ability to interact with the world around it and with the humans needs to be better. But we also need power efficiency. So we need next generation batteries that support longer operational periods. And maybe this is an interesting investment area, because there's a lot of new work on battery technology. We also need enhanced dexterity. We need better perception. We need better sensors. These are all interesting areas by themselves. They also need to get better solutions that are adopted by humanoids in order for humanoids to work better.
I think we're getting close to time, so we want to quickly pivot the Q&A. But someone had asked about valuations, and that was one of the things we were going to talk about today. But I thought this chart that I pulled from FactSet kind of highlighted where we're at and what's different from the previous highs of the tech cycle in 2021. We've obviously seen the market kind of sell off and recover a little bit in 2025 so far, but the Think Artificial Intelligence Index right now is trading at its biggest discount to I think we have the Qs here as an example of mega cap companies, it's at a 30% discount. So, when you think about, are we in an AI bubble, we're actually at values similar to, the bottom of 2022, which is when NVIDIA started its multi-year long growth cycle. So, in our opinion, our view, we've seen solid and for the most part, EPS and sales projections from earnings season holding strong. We've seen data center CapEx remain strong. Microsoft might be the only one that's pulled back at all, and they've admitted they went a little over, and that's just part of it. So, from kind of a timing perspective, we are at an interesting period where kind of this big opportunity in artificial intelligence is literally at a discount, and it had previously been at a premium. So again, this was just something wanted to highlight before we finalize this. And okay, we can start with Q&A while we're on this slide.
So Alex, so Zeno, I can take a very quick question if there is one, but I have to go to my next meeting.
Okay. Okay. I wasn't sure if there was one that you had seen on the right hand side. Yeah,
right.
we have. If there's anyone that pops out to you, because.
Okay, so I don't know. I'm trying to get familiar to your to the
system.
interface.
Yeah, it's a bit wonky. Let me see. I'm trying to pull one. Let's see. There's a lot of great companies about time frame for liquid AI technology to be commercial.
Now, so in fact, we are very aggressive. So we have aggressively signing customers, and we have actually a lot of really exciting products and customers already working with us. And I don't think I can get detailed about that right now, but maybe we can reconnect in about a month and I will be able to say more about that. But yes, the company has closed Series A, and the focus for 2025 is customers and revenue. And we have very high aspirations for the amount of revenue we expect for this year.
That's awesome, and can't wait to see that. Hopefully that'll start trickling through different ecosystems and lives and benefiting. If you have time for one last question, there's two questions I want to bundle in. I know you do need to go, but there's a question on AI being tampered with and kind of just like security to hacking. And my first thought is just like the observability layers will be very important for making sure that everything's operating. Like we have an entire subsector dedicated to companies in that cybersecurity and observability of analyzing for nuances. But wondered if, I think there's a lot of opportunity, but I think there are concerns around, the hacking and ability for it to,
So what I can say very quickly is that this is a valid concern, because these great tools we're building empower good people. They also empower the supervillains. And so the question is, what can we do to prevent the supervillains from abusing the tools? And part of the answer is regulation and laws. But part of the answer is also technical solutions. And perhaps I can share with the group here that we are developing, the community, is developing technical solutions to prevent cyber attacks. The safety of AI systems is a very important research topic right now. And we will see accelerated deployments of the ideas that start in research.
I'm very excited to see more of those technologies coming about. I know you need to run. I know we're out of time. Thank you, everyone, for joining us today. Thank you, Daniela. Always a pleasure to have you on. And if there's anyone, I know there's a lot of questions we weren't able to address. We'll respond. We'll try to respond individually to all of you because I appreciate your engagement. Again, Daniela, thank you. Hope everyone has a great weekend, and see you next time.
Nice to be part of this. Thank you, everyone. Bye-bye.